Now our next problem is problem number 4. Determine the dimensions of I section shown in the figure, in which both extreme fiber stresses are numerically equal in pure bending. Also find the maximum stress if the load is 20 kN and Bi plus B0 is equal to 125 mm. Now this is shown in the figure. This is for sugar. The figure as shown here. This is a unsymmetrical I section, and the line of action of force is coincide with the central line of the curvature, that is given 75, and Bi B0 is unknown. Then is given condition Bi plus B0 is 125 mm. Then the distance of the web or thickness of the webs are given. Right, this is called as a flange. Web is a top flange, web bottom flange. Now redraw this sketch. This is a redraw this sketch with the notations, and write the given data. What are the data are given? Ra is given, R0 from the figure calculate. Then the C1 plus C2 is equal to this one. Then Ci plus C0 is equal to this one. Then load is given and the condition is given. And one more condition is given, is a cross section, type of cross section section. One more condition, both extreme fiber stresses are numerically equal in pure bending. What it means? Both extreme fiber stresses are numerically equal in pure bending. Due to pure bending, the stresses are same at the inner fiber and outer fiber. What type of stresses? Bending stresses. The bending stress in inner fiber is equal to bending stress at outer fiber. Our aim is to determine what is Bi and B0 and also stresses induced at inner and outer fiber. Now compared to previous problem, in the first and second problem, our aim is to determine only stresses induced in the cross section, critical section. In problem number 3, our aim is to determine what is an external. Third problem, our aim is to determine what is an external force or the maximum capacity that the beam and curved beam can withstand. Now the third variety of problem is I want to determine what are the dimensions of the section. Right, these are the varieties. This is the third variety problem. Right, now once you write the given data, now what are the other data? Now here the cross sections are unknown, the cross section dimensions are unknown. Then other data don't go for directly. Okay, so condition other dimensions. From the other dimensions, first is what are the conditions given? Take this condition. Both extreme fiber stresses are numerically equal in pure bending. That is sigma Bi is equal to sigma B0. Now you cancel it. Now you will get Ci in terms of C0. From the figure is given Ci plus C0 is equal to 100 mm. Now substitute the value of Ci here and we will get C0. And also back substitute C0 to the equation 1, you will get Ci. Ci is nothing but the distance from neutral axis to the inner fiber. C0 means the distance from neutral axis to the outer fiber. From this you will calculate the what is the radius of neutral axis, that is Ri plus Ci. Now this is Rn is equal to 105 mm. Right. Next, now we will refer other data again from the earlier 2-3 problems. We consider first table to 2.7 because already cross sectional dimension is given. But here first we take the table 25.2 because already we know the neutral axis, the radius of the neutral axis. Refer table 25.2 for unsymmetric high section. Again redraw that unsymmetric high section, the sketch with the notations already available in the data handbook. Right, then from that figure and the given problem data, and then once again rewrite the data according to the sketch. Right, after that only write the what is the radius of the neutral axis. The formula is given in the, now refer that equation. Check, it may be a 25.63. verify it, this equation number. Then substitute. We know that what is A. A is the vector sum of all the A's, where I is vary from 1 to 3 portions. Portions number 1, 2 and 3. These are rectangular portions. So top flange, web and bottom flange. Now substitute A1, A2, A is nothing but rectangular flange, it is breadth into height. Now substitute formula and they take the 25 is a common from these two, we'll get Bi plus B0. As you know, Bi plus B0 is 125 mm. Then you substitute, get cross sectional area. Then already remaining data already we consider here and from the given data. Now substitute that value, already Rn also we calculated, substitute. Now we will get this equation. Now here also we know that Bi plus B0 is equal to 125. Substitute Bi in terms of B0 into the previous equations. Simplify it. Finally we will get the values of B0 33.361 and Bi. Then how do you check the top flange B0 is less than Bi, right? Verify it, right? Then after the once you calculate dimension Bi and B0, again our aim is to determine stresses induced, right? Before that, again refer the table 2.7. we can't find unsymmetric I section in the table 2.7. again redraw that again I section and write the notations. Then as you know that from the elements of civil engineering, I think, or in mechanics of material, already we studied this, how to determine the centroidal axis from the inner fiber or from the bottom line or the x-axis to the this is how do you determine, you know the formula, well-known formula, that is, you know the distance from the centroidal axis from inner fiber is y bar is equal to vector sum of ai's yi's divided by summation of ai's, right? This is equation because three flanges are there. This is the equations you'll get. Now calculate what is a1, a2, a3, right? Then sum vector sum already we know this. Again if you want you can verify it. Then y1, y2, yi's are the distance from the inner fiber to the center of the corresponding rectangular boxes or the flanges. So this from inner from the bottom line to the CG of the first block, then from bottom axis CG of the second block y2, from bottom line to the CG of the third block y3, right? Then yes, once you calculated a's and yi's, then substitute to the equations, then get y bar is equal to c1, right? What is y bar? Y bar is from the inner fiber to the centroidal axis, nothing but is a C1, right? Y bar you get 37.512 mm. Then as you know the C1 plus C2 is 100 mm, then you calculate C2. Then you can calculate the radius of the centroidal axis from the geometry or from the figure, you get Ri plus C1. Now that is RC is equal to 112.51 mm. Again verify it. How do we verify? RC is greater than Rn, right? Rn will get 105 mm, RC is 112.512 mm. Then calculate eccentricity, you will get 7.12. Then distance from the line of action of force on the centroidal axis. Now in this problem is L is equal to RC here. By seeing the geometry you can get. Then what is the bending moment is equal to force into distance, you will get. Then what is the maximum stresses at the inner fiber? Already know that from the equation 25.55 I think. Then you'll get this inner fiber undergo tensile and 25.54, or you can know the conditions given. The bending stress at inner fiber is equal to bending stress at outer fiber. Then you'll get this one, but compressive in nature. Yes, thank you for watching this video. If you have any doubt, please ask the question or send the question to my WhatsApp number. Thank you for watching.